So what is the quotient? No, not necessarily a quotient. Quotient is associated with what? Okay, so all of these are quotients. An expression divided by something. We want to not write them necessarily as quotients. We want to write them as a sum or a difference. So adding or subtracting. Which one do you think is the hardest? We can do that one. 4. Okay, 4. Do you think it's harder because of the fraction? Okay, that's fair enough. So let's do 4 together. Now it's a rule, and where you write this rule, maybe like in the margin somewhere. If you have something that is like this, it can be written like this. All right, so anything that is being divided by something, like any expression, you can actually write it like separately, where each term is divided by that same thing. All right, and that's going to be really important in this unit, which is probably why we're starting it as a warm-up today. So to rewrite it, I'm basically going to separate each term. Hopefully you remember what terms are and how you know when a term starts and ends. But that's going to be this plus 5/2 like that. Now we're not done because does not look a little ugly. Okay, so you always want to simplify wherever you can. So over here I have a fraction divided by 2. Are you guys familiar with like copy dot flip or keep change flip for dividing fractions? Yeah. All right, if you're not, I'll familiarize you with it, and I'll also show you how to do it in depth. So there's no reason you have to like avoid fractions just because you didn't remember that one rule is not great. All right, so for copy dot flip, anytime you have fractions being divided in any sort of way, you copy the first fraction. I'm going to leave the x out of it for a second. Copy the first fraction, change the division to multiplication. So copy, dot, and then you're going to flip the second fraction. 2, the way it's written is technically not a fraction. How could you write 2 as a fraction? How can you write any whole number as a fraction? 2/1. Yeah. Yes, so that's what it is as a fraction, right? But according to the rule, we're going to copy, dot, and then flip. So it would be 2/1 over here. Now it's going to be times 1/2. Flip it. And then you can just multiply straight across. So like -1 times 1 is what? 5 times 2 is. And you could simplify that if you needed to, but that's already simplified enough. So then it becomes -1 over 10x. And then can I leave it as 5/2? Yeah. Is it a simplified? I mean, it's allowed to be improper, but is it simplified as much as it can be? If I'm leaving it as a fraction, it's simplified as much as it can be. You could technically make it a decimal. That might make it easier for when you graph it, but you don't have to graph it in this one. What is the equivalent decimal to that? 5/2. 2.5. But you could leave it like this as long as they're simplified fractions, and that meets the whatever you call it. That means writing it as a sum or difference. Let's do one more, and then I'll actually have you try together the others. So would you rather see number 1 or number 2? Okay, I see more 2s than I see 1 of the people that voted. So let's look at number 2. All right, so follow the rule that whenever you have something written in this format, you can actually rewrite it like this. So in that case, I'm going to write each term over the denominator, right? To kind of split it up. I would just rewrite it, and then in the next step, I can do any simplifying or things that need to change. So is the 1 over -2, is that fine the way it is? It is. I will say, especially for this unit, just as a habit, put the negative in the numerator. It doesn't change anything, right? But it'll help when we get to graphing. So just as a habit, if there's a negative, put it in the numerator. But then over here, I have a -50 x divided by -2. What does that simplify to? Positive 25x. All right, so a negative divided by a negative gives me a positive. 50 divided by 2 is 25. That happens to be a whole number, so I don't have to write it as a fraction. And then the x is still there. And that meets the writing it as a sum of difference. Okay, so I'll give you about a minute to do the other two that we didn't do together. Now that you have at least some background on it, and then we'll see if you're right. Table 6, what did we get for number 1? As like a final answer, you could tell me. 2x minus what? All right, class, good, like it, dislike it. All right, no comment. Yeah, all right, so let's see, just in case, I'm sure there's some people out there that have no clue what's going on. All right, so follow the rule. If you have it written like this, you could also write it like this. I think it makes the simplifying easier. I know some of you could probably simplify that in your head by just remembering to divide each term by the denominator, but I just think this is easier too. Less mistakes made. So then you break it up, then simplify where you can. What's 4 divided by 2? Good, and the x is still there, didn't magically disappear. And then what's -10 divided by 2? Good, so that's why it's -5. Questions? Could I also write plus -5? You could, like normally we would just put -5, but it means the same thing in case you were wondering. Table 7, can you tell me what you got for number 3 as a final answer?
2.5 plus 2.
2.5 plus 2? Okay. So let's see, in this one, how is this one different than the others? What did you have to do first? Good, you had to distribute. So anytime you see it in that format, distribute first. That comes first in like every situation that I've seen that I can think of. So you have to distribute first. So I get 5 times x, which is 5x. 5 times 10, which is 50. All right, so that's me distributing first. Then I'll separate it. I know some of you like to combine steps, but I like doing this, less mistakes that way. All right, and then simplify where you can. So over here, I have 5 over 25. Should that give me 2.5? Because I have a smaller number on top. So I should actually expect whatever decimal it is to be smaller than 1. So let's see what that is. 5 divided, or we could also leave it as a fraction. So what goes into both 5 and 25?
5.
So 5 divided by 5 is
1.
25 divided by 5 is
5.
So it could be 1/5 x, and then that same decimal would be 0.2. In case you were wondering. All right, and then what about 50 divided by 25?
2.
And it would be positive, so we're gonna put +2. All right, because does that make a little more sense? If you made a mistake, that's fine, just fix it, see your mistake, and then we'll move on from there. Questions? All right, so then good warm up. That's a really important skill that you need to know for later. All right, so let me show you what the goal is today. This lesson has the same title as yesterday's lesson, but it's a part 2. So connecting equations to graphs, lesson 11. We only have 17 lessons total for this part of the unit, so we're gonna take the unit tests, not next week, but the week after. Okay, so this week and next week, all instruction, week after testing and retesting. So today's goal is to analyze different forms of linear equations and how the forms relate to their graphs. What are some forms of linear equations that we already know? What equations give me a straight line when I graph them? Y equals mx plus b, that's called slope-intercept form, by the way. And then we saw another one yesterday and even before that, but I didn't tell you the name of it. It's called standard form. And it is in this format. Right? All the problems we graphed yesterday were in this format. And then we rearranged it to slope-intercept form. There's pros and cons of each. And we can talk about that again later if there's time, but those are our 2 forms for linear equations. We're going to see how they relate to their graphs again. You're going to be able to find the slope and y-intercept. They call it vertical intercept a lot. Hopefully you know vertical axis is your y. But we're going to be able to find slope and y-intercept of a line with equations in either format. And being able to rearrange the first equation into the second one. And then using strategies to find slope and y-intercept of the graph when it's given to you in different forms. All right, so continuation of yesterday. I'm recording now. It'll be linked in the slides like always. Puzzle piece will be lesson 11. Again, I've shortened them quite a bit. Like last year, my students had about 10 questions per assignment and they were like all word problems. I've really cut it down. So please do them. If you have questions, please ask for help. The people that have been doing the homework tend to do better on the quizzes and the tests. Like that's just how it goes. Like if they can understand everything on there, they usually perform better. So highly recommend those. And then next quiz, last quiz of this unit will be Monday. So questions on anything? All right, I do have office hours today after school. There's also a Saturday Academy, which I'll send an email home to you and all your parents inviting you, regardless of what your grade is. I just think it's a great opportunity. Like there's real teachers there, not just like some random kids that are supposed to be honors kids or whatever. I mean, not that that's bad, but like there's real teachers there. Normally to pay for like tutoring is like a minimum of $40 an hour if you hire a private tutor. Like these people will help you and you don't have to pay anything for free. Anyway, I'll send a message home with all our information. But they have Saturday Academy about once a month. So really great opportunity. All right, but moving on. So for today's activity, and you should see this on your paper too. This is a graph that represents a situation that you might have seen in earlier activities. We have 450 minus 20t. You're going to describe the relationship between gallons of water in a tank and time in minutes. And then in your groups, you're going to discuss these 2. Where on the graph can we see the 450? Where can we see the minus 20? And what do they mean in that situation? All right, I won't give you any more guidance yet. I'll let you talk it through with your groups for about 2 minutes.
This question is really great for assessments. They love to like ask you to interpret what the slope and y-intercept represent and things like that. So it said describe the relationship between the gallons of water in a tank and time in minutes. Table 8, can you describe that best you can? Okay, so when time increases, gallons decrease. Is that something you guys agree with? Do you know how to tell if that's true?
Alright, well, let's see. Time is on the x-axis, usually some form of time is on your x-axis. And as we go to the right, the numbers get bigger. What's happening on our graph? The amount of gallons is going down. So yeah, I would agree with that. Did anyone describe it differently? Parker? Okay, so for each minute. I can't spell today. Sorry. For each minute. The gallons decrease by 20. All right, so is that accurate? So let's see, it starts at 450. 1 minute would be in between the 0 and the 2, right? So you might have to estimate right here. About how many gallons is that? Does it look like about 20?
Yeah.
Okay, and then if we go one more. Does it look like it decreased by about 20 again? Good, it doesn't go right in the middle of those like crosshairs is what I call them, like the grid lines. So you know it's not gonna be 400 exactly, it looks more like probably 410 if we're following the relationship. So, yeah. You can also tell not by looking at the graph, but by looking at the equation. Where in the equation does it tell you that? What part of it? The negative 20t. T is minutes. Every time you plug in a minute, you can do the math. You see it's decreasing by 20 each time. All right, so I think that's good. For where on the graph can we see the 450? Table 9, what do you guys say? Where on the graph can we see the 450? Is it class? Is it the x-axis? It's the y-axis. And what? Well, I guess that answers it. On the y-axis, specifically the y-intercept. All right, so if you get your axes confused, you could remember this. X to the left goes from left to right, Y to the sky. It goes up and down. Okay, so yeah, 450 is on the y-axis, right where the line starts. Table 1, what about the negative 20? I don't see anywhere on the X that there's a negative 20. Think about how we do it decrease by 20. Where on the graph is that? On the line itself, specifically, like what part? What about the line? Like I'm trying not to give you the answer, but like what math term would we use? Where we see the negative 20. The slope. So the negative 20 is seen on the slope, which is like your steepness of the line, right? That's how we saw it. We literally counted it. Okay. And what do they mean in that situation? Well, you can refer back to this. For each minute, the gallons decrease by 20. Questions on that? All right, so good. Now, different activity. And I think you guys will like it. For this activity, you are able to either work it out by hand or use Desmos. So highly recommend try it with both. So on the back side of your paper, what you are going to be doing is matching each of these equations with the correct slope, which we use m, and the y-intercept of its graph. You can use technology or rearrange the original equation for that. I'll kind of let you go at it before I give you any sort of like tips or strategies. You'll kind of see when it's easier to use one over the other. All right, but show all work or talk about how you use Desmos to match each one correctly. I'll give you, since there's like 5 of them, class tends to be a little bit longer. I'll give you like 6 minutes to start.
So 4 was the one that was requested that was hard to match. So let's see. Because I haven't given you guidance. I mean, I've given you guidance on the other lessons, but not for this specific activity. So you have 2 methods of figuring it out. You can either use graphing technology or rearrange the original equation. I can show you both. I'll do the rearranging because that's just such an important skill, especially in this unit. What format are all these equations in, by the way? Good, they're in that ax plus by equals c, or in other words, they are in standard form of our linear equation. If we're trying to find the slope and y-intercept, what form is probably the most helpful? Is it going to be standard form? No, do you guys remember what the other form is called? Or the equation for the other form? Y.
Plus 8.
Okay, and that's called slope-intercept form, by the way. Why, you might ask? Because you can clearly see the slope and the y-intercept. So that's why it's suggested maybe try rearranging it into slope-intercept form so that you could clearly see your slope and your y-intercept. So slope is always your m, always in front of the x, and b is your y-intercept. That's always like the single number that is there. All right, now number 4 was the one that was requested. If I want to rearrange it to slope-intercept form, what needs to be isolated? The variable y. Okay, because look at slope-intercept form. It's alone on one side. So if I can just get the y to be alone, then I put it in slope-intercept form. So here it is in standard form. If I want to get the y alone, usually whatever you try to isolate, I tell you start with what's farther, because it does make a difference. What's farther, the 1/3 or the negative x from y? The negative x is farther, so you have to get rid of that first. How do I cancel the negative x? Adding x, and whatever you do on one side of the equal sign. Okay, good, so that'll cancel here. I have 1/3 y equal to, are these like terms on this side? No, one of them has an x, the other one doesn't. What I will do though, to make it look more like this, I will put the x term first. You don't have to, but I recommend you. And that's allowed because I'm not changing any of the symbols at all. The x is still positive over here and the 1/3 is still positive. But now it just looks more like mx plus b. But we're not done because there's the y alone. How can I cancel that 1/3? Not subtracting because it's not 1/3 plus y. All right, we want to get the y alone. I could divide 1/3, which if you remember, copy dot flip. Copy the first one, change that to multiplication, flip the second one. So you could phrase this two ways. You could divide by 1/3, or you could multiply by 3/1. It's literally the same thing. I think multiplying by the reciprocal is easier, so that's what I'm gonna do. But either way, you can use a calculator. So it's not a big deal. But whatever you do on one side of the equal sign, you do to the other side. So that cancels this fraction. I get y alone now. And on this side, I need to multiply or distribute by 3. What's 3 times x? And what's 3 times 1/3? Either use a calculator or do it by hand. What's 1 times 3? Okay, well, now I'm asking a different question. So what's 1 times 3? And then 3 times 1? 3 times 1? And then what does 3/3 simplify to? Okay, good. I think that's what you meant, but you answered it too late. So this is it in slope-intercept form. Which one shows a slope of 3 and a y-intercept of 1? Answer option A, so 4 matches with A. I will also show you graphing technology. You can decide which one you like better. As long as you get to the right answer on the test, I don't care. But I would use Desmos as a checkpoint, not as a starting point. All right. I've shown you how to graph with Desmos. Listen, children. I've shown you how to graph with Desmos. Here's a reminder. Desmos only reads X's and Y's. Do I need to rearrange it in order to graph it? No, that's the good thing about it. I don't have to rearrange it. In some of your graphing calculators, you might have to, but in Desmos, you don't. So I'm typing in number 4 exactly how it looks. If you don't know how to make it look like that, ask me and I can show you. But then if you're trying to find your slope and your y-intercept, you're going to have to really look at the graph and know how to do it from a graph. Y-intercept is pretty easy. All right, remember y to the sky, look at the vertical axis, and it even will easily mark it for you. It actually marks your y-intercept and your x-intercept. But for slope-intercept form, we want the y-intercept. So my y-intercept is 1. If I look at my answer options, there's 2 that have a y-intercept of 1. So then I have to really check my slope. If one of them was negative, then I could immediately cancel out that as an option because clearly the slope is positive. But 2 of them are positive, so now I really have to check. How can you check slope from a graph? Rise over run. So find 2 areas where you could see the points really clearly that you don't have to estimate. So I'll pick my y-intercept and then I'll pick this one. And also the way that I'm zoomed in, each tick mark is 1. So that kind of makes it easy. On some of them, you might have to really check your tick marks. But if this is on paper, then I would connect it with the triangle to make it a bit easier to see my rise and my run. So if I'm going from 1 to 4, what's my rise?
3.
Good, 3. All right, so don't count the one you're starting at, count 1, 2, 3. That's my rise. And it's positive because I'm going up. Your run, if I'm going from 0 to 1,
1.
is 1. Rise over run, 3 over 1, that's my slope. So either way, you're having to do a little bit of work each time. Whatever's easier for you, whatever gets you the right answer, go for it. I'll give you 1 more minute now that I've given you a little bit of guidance to try and get the matches that you weren't able to get. If you think you already have it, great. You can open up your Chromebook, start your practice while we give our peers 1 more minute. Table 2, what did you say that number 1 is? B, did anyone get something different for that one? Okay, so we're saying that one has a y-intercept of 1, a slope of 4/3. Well, we already matched A, so let's just maybe type that one in and see if that one has a y-intercept of 1. So then using Desmos, I'm typing in number 1. And that y-intercept is 1. We already matched the other one that had a y-intercept of 1, so that one is a good match. So 1 should be B. Good. Table 3, what did you say that number 2 should be? D as in dog. All right, anyone disagree with that? All right, there's no disagreements, then we'll keep going. Table 4, what did you say that 3 should be? Or, yeah, table 4, number 3. And an elephant. All right, anyone disagree with that? Now, forever will be peace.
Wait.
Okay, we're having some disagreements about number 2 now, so let's see. Okay, so typing in number 2, first I'll check the y-intercept. That tends to be the easiest to see on a graph. So D says that y-intercept is 8 when clearly it's -2. So my options for number 2 is either C or E. Everyone see that? If you made a mistake, you were probably, don't know how you made that mistake. I don't know. But I don't know. It cannot be D for number 2. Your options are either C or E. So they both have positive slopes. We could examine that about what slope it has to be. Find 2 areas that are easy to see. So I'll pick the y-intercepts. And it looks like this one goes nicely through the graph too. So you could connect them with a triangle. Highly recommend good strategy, especially for geometry too. What's my rise here? 1, 2, and 3. Yeah, and it's positive, so it should stay a positive 3. What's my run? 1. So my rise over run, 3 over 1. Which one matches better? E as in elephant for number 2. Which then means now we have a problem with 3 because that can't be it. That one is D? Yeah. So then process of elimination, did you all get C for the last one? Yeah. Okay, is there any specific ones you want to see worked out? Okay, let me check my little answers to you real quick. All right, now it is correct. So make sure you adjust those. Make sure you either know how to rearrange it or know how to use Desmos. Write something down on your paper to help you regardless. Questions, comments, concerns? All right, I will leave you to work on your practice. You can pack up at 8:14, no earlier.